August 20th, 1975, the first Viking spaceship was launched. Just 2 weeks later, there was a second Viking launch. Together, they began to search for Martian life.
2 orbiters, 2 landers, headed for 2 different locations on the Red Planet. It was a gutsy mission.
It was one of the biggest adrenaline rushes of mine or anyone's life, and the story, as it unfolded, was a classic example of scientific discovery.
Nav is green for touchdown. ATS is green, 1.5 degrees per second max, 0.2 Gs. Speed first. Touchdown, we have touchdown.
We didn't know then what we know now, which is how tough it really is to land on Mars.
12:50. That is 35 minutes from now. The playback of pictures will start, as I understand it.
A moment in every Viking's life that he or she will never forget. Sitting with that television right in front of him and watching as the first lines came down. It came down line by line by line.
By the time we could see 5 or 6 lines, we could actually start seeing the outline of a rock. And you saw 1 section, and 2 sections, and 3 sections, and you started seeing the surface of Mars. And then you knew we had done it.
There's no way to describe it. We were lifted up. It was, everybody kept walking around. This photograph will be in the book 1,000 years from now.
Viking gave us the first view of Mars as if we were standing on the surface. It lasted over 6 years, but never did find conclusive evidence for life on the Red Planet.
After all, that was the whole purpose of the Viking mission, was to go and land on the surface, scoop up some soil, and see whether or not this planet had developed life. Well, we're still looking for that life, but today we think it's in particular areas. It's not just anywhere on the planet, so we have to be special about where we go to look for it.
Viking did provide a wealth of data. It mapped the entire planet and charted seasonal changes. People began to see the real Mars. Every time we've gone to Mars, we've increased our ability to see details, and we've seen a brand new Mars. But for a Viking, no picture could ever be more powerful than the first one.
Every single time we have gone there, it's been a brand new Mars. But the biggest brand new Mars of all time was in July of 1976.
At this point, you may be asking, what is the NASA connection here? One of NASA's main goals is to discover if life exists in other worlds. So what we have to do is we have to form that operational definition of life, and we have to look at life here and compare it to life in other places. For example, if you take a look at the planet Earth, we can look at this place and we can see right off the bat that there is a lot of life going on here. Kids will look at this and they'll say, well, the trees are growing, the sky is blue, there's oxygen that I breathe. One of the things that's probably not quite so obvious to the kids is the question, it could be alive now, but was it once alive? What on this particular planet was once alive? We have to be able to answer that particular question because we want to go to other worlds, such as the planet Mars. So if we take a look at Mars, you'll notice that this particular landscape is completely different than the landscape that we saw on Earth. Here you see nothing obviously growing. There's no trees, there's no plants. So the question arises, is there life on this particular planet? We have to go back to our operational definition of life, and we have to start taking soil samples. Again, that's what this project is all about, is taking soil samples, and using those soil samples, we must determine whether life exists or not. We sent a rover there, the Viking, in the mid-70s, 1976, and one of its prime missions was to determine if life existed on this particular planet. So it ran some experiments, the end results being inconclusive. It could not make a determination on whether there was life there at one time or not. It did take a lot of pictures. The pictures were not all that great. They were a little bit grainy, a little bit blurry, but we do have some of that film segment. So let's pause for just a few minutes and take a look at some of that film.
Viking gave us the first view of Mars as if we were standing on the surface. It lasted over 6 years, but never did find conclusive evidence for life on the Red Planet.
After all, that was the whole purpose of the Viking mission, was to go and land on the surface, scoop up some soil, and see whether or not this planet had developed life. Well, we're still looking for that life, but today we think it's in particular areas. It's not just anywhere on the planet, so we have to be special about where we go to look for it.
Viking did provide a wealth of data. It mapped the entire planet and charted seasonal changes. People began to see the real Mars. Every time we've gone to Mars, we've increased our ability to see details, and we've seen a brand new Mars. But for a Viking, no picture could ever be more powerful than the first one.
Every single time we have gone there, it's been a brand new Mars, but the biggest brand new Mars of all time was in July of 1976.
Let's take a look at another mission to Mars. The Odyssey is a satellite that circled Mars and took pictures of the planet's surface. Now, these pictures were much better than the grainy, blurry pictures that the Viking took. It's actually capable of taking pictures in 3 different modes. It took pictures in visual, it took pictures with gamma rays, and it also took pictures in infrared. These were the better pictures that we got back from Mars. As a matter of fact, I believe that we have some of these pictures in the very next video clip. So let's pause for just a moment and take a look at those.
The camera on Mars Odyssey is called Themis, and it actually is 2 cameras in one. It's a visible light camera, taking pictures like you would see with your eye, and it's also an infrared camera. So we're able to really learn a lot about the composition of the surface, what minerals make up the surface. It's really a powerful tool, and we've created now 2 maps, one in the daytime and one in the nighttime, each of which is the highest resolution global map ever acquired at Mars.
I got interested in Mars when I was a kid. My mom bought me a telescope when I was about 12 years old, and I've been looking at Mars ever since. I was fascinated just because it was this tiny little place a long ways away, and people were trying to speculate what it was like. So all my life I've been trying to take better and better pictures and get closer and closer to help sort of imagine what it would be like to actually walk around on that planet.
We have Odyssey to thank for this next slide. As you can see, we sent another robot to Mars, and it was called the Phoenix. It was a pretty much stationary robot. It went to the North Pole. This particular site was chosen from Odyssey. When Odyssey looked at the North Pole of Mars, it noticed that there was a sheet of ice, or what appeared to be a sheet of ice, underneath the surface. So Phoenix was sent there, and it landed, and it conducted experiments on the surface there. As it dug through, we did notice these white deposits, and scientists were actually able to confirm that there was frozen ice deposits underneath the surface on the North Pole of Mars. After Phoenix, we have another rover that is actually being born as we speak. This is Curiosity. Curiosity is a roving laboratory. It's much bigger than Spirit and Opportunity that are on Mars right now. And it is right now in the Jet Propulsion Laboratory in Pasadena, and it will be launched in the fall of 2011. That leads us into the next video segment. I think we have something on both of these rovers, so let's pause for a moment and take a look.
Phoenix was a Mars lander mission. In 2008, it landed in the North Polar region of Mars. That's about equivalent to Alaska latitude on the Earth, or mid-Greenland. And its job was to land, dig down, and sample the soil and ice that it encountered in that region of Mars.
Mars Science Laboratory will have sophisticated instruments which will be able to look at the mineralogy in much more detail, but also looking at minerals which either were formed by organisms, living organisms, or show signs that living organisms were around when they were formed.
Water is a basic fundamental condition for life to exist. So when we go to Mars and we look for life, we follow the water. Thanks to the Odyssey, the Phoenix, Spirit and Opportunity, we know that Mars does have a supply of water, so we follow the water. Curiosity is going to be doing that for us. When we look for life on Mars, what kind of life are we going to be looking for? probably not something that resembles you and I. More than likely, we're going to be looking for something that resembles the paramecia or the amoeba that are located right here on Earth. Let's take a look at this next video as it explains to us why water and energy are very important for the creation of life.
Water is a necessary component for life as we know it. So when we think about trying to understand life on other planets, one of our strategies is to understand the water.
We're focusing on Mars because Mars, in its early history, may have been a lot warmer and wetter than it is now.
It looks like there used to be flowing liquid water on the surface of Mars, but today there isn't any liquid water that we can find, or if there is any, it's very infrequent.
We're not looking for aliens. We're not even looking for fossils. We'll be looking for bacteria or signs of bacteria. And the reason for that is because for most of the Earth's history, they have been the predominant form of life. The chances are it may be different from life on Earth, and therefore what we have to look for is it doing the same things that life does on Earth?
Sometimes when we're trying to decide whether something is alive or is not alive, it's not as easy as what this picture looks like. Obviously, in one picture, you can tell that something is alive as opposed to not alive. Most of the time, it's not as easy as this. So in the classroom, when we're doing this activity, you want to come up with some discussion questions. You want the kids to be able to talk about what the characteristics are. So they're going to have to come up with some type of criteria for something that is living as opposed to non-living. So the first thing that we're going to do is we're going to develop a criteria. So we have a list here for criteria. The first criteria that they might come up with is, does it react to its environment? The second criteria, does it adapt to its environment? The third one, it must reproduce. The fourth, does it grow? The fifth, does it obtain and use energy? And the last one, it could be made up of cells. Now this particular list, you could adapt it to your particular grade or your particular classroom, but basically the list is going to be the same. And after they've developed the list, that's when they go back and they can actually start the project. Welcome today. I'm glad that you could come to the classroom. We're going to be studying about life. How many of you think that you could recognize life that exists around you? Raise your hands very quickly. Okay, great. Can somebody give me something in the classroom that is not alive in your opinion? Yes, in the back.
This pencil.
That pencil, okay? So when we go to other worlds, like Mars, we would be looking for life. What would you be looking for if you were a scientist?
Something that gives off oxygen.
Something that gives off oxygen. Sometimes the things that we find are very, very tiny, microscopic, if you will. Or maybe it was alive, but it's fossilized now, and we have to determine, was it once alive? We're going to have to establish some type of criteria. On the board behind me, you see some definitions or criteria of life that we're going to be using in this particular activity or experiment that you're going to be doing in just a moment. Hi, now each one of you has been given 3 samples in front of you. No one knows if there is life or not in any of those samples. It is your assignment to determine, using the criteria on the board behind me, if there is any type of life that exists in any one of those samples.
You've just seen the students introduced to the lesson. Now these are the materials that you'll need for your classroom. A beaker, magnifying lens, scissors, teaspoon, Alka-Seltzer, active dry yeast, sugar, and sand, both coarse and fine grain.
They're also going to need some paper towels for the classroom to clean up any of the spills. We also have a couple of student recording sheets here. All the observations that the students see in the classroom should be recorded on their recording sheets for future reference. What we're going to do with the fine-grained and the coarse-grained sand is we're going to mix them in equal increments in beakers A, B, and C. Now, all of the mixing should take place before the students arrive in the classroom because we don't want them to know what's actually inside the beaker. So again, we're going to fill them about 1/4 of the way full with the sand, and then we're going to take 5 milliliters of sugar, and we're going to mix those in beakers A, B, and C. And then for beaker B, what we're going to be doing is we have a little package of active dry yeast here. We're going to open that up and we're going to put it in beaker B and we're going to mix it up nicely so the students can't actually see the sugar or the active dry yeast. And then in beaker C, we have a little wafer here of Alka-Seltzer. And as you can see, if I actually drop this into the beaker, the kids are going to find it right away. So what we want to do first is we want to pulverize this into a very fine, fine grain. And then once it's pulverized, we're going to put it in beaker C, and then we're going to mix that up so the students have a hard time identifying any of the ingredients here. So let's return to the classroom right now and find out how the students handled the first part of the experiment. Ladies and gentlemen, you now have your instructions. So what you're going to do is to test sample A first, or test one sample. Put some on your hand, put some on the paper in front of you, use a magnifying lens. Take a really good look at it. Before you go to the next sample, make sure that you record your data on your paper and then go to the next sample. Make sure that you indicate whether you think it is alive or not alive. We should be just about finishing up the second sample and getting ready to start on the third sample. You think that looks like chalk? Well, that's a really good observation. Make sure that you write that down. Let's take a look at sample A. How many of you think that there is something in sample A that is alive? Raise your hand. Okay, let's go to sample B. How many of you think that life exists in sample B? Raise your hands. Okay, let's go to sample C. How many of you think that there is life in sample C? What I am hearing you say is that you have actually no proof that anything is alive in any of these samples, but what you are saying is that maybe things in these samples are an indication that life exists in that environment. Is that what I'm hearing?
The students just looked at the dry samples in the classroom. Now let's see what happens next.
Okay, what we're going to do with the samples now is after the students analyzed what they saw, they did their observations, they recorded their data, they came to a consensus that there was not any life that they could observe in samples A, B, or C at this time. Although a couple of students did indicate that they thought that maybe life could exist, in some form in this material, they just did not see it. So what we're going to do now is we're going to go into the second part of the experiment here, and we're going to add some tepid water into beaker A, and we're just going to put enough water in there that it barely covers the soil. The students are going to pick up their magnifying lens, and they're going to observe the reaction that's taking place in beaker A. And as you can see, there's not a lot going on there. Okay? After the students record their data there, they're going to go on to beaker B, and they're going to do the same thing. We're going to add just enough water to cover the sample, and they're going to be watching this, and first thing that they'll probably notice is that it did change color, which is a sign of a chemical reaction. But there's not a lot happening there right now either, so we're going to come back and look at that again later, and then we're going to go to beaker C. And again, we're going to, whoa, take a look at that. Wow, okay, we have an immediate reaction here, and the kids are going to watch this. They're going to record what's happening. So what I want to do right now is I want to go back to the classroom and see what the kids came up with, and then we'll come back and we'll revisit our beakers A, B, and C. The second portion is we're going to be applying water to our samples. And you're going to cover your soil sample just so all of the soil is covered. That's all the water that you need in it. Take a look at it. Use a magnifying lens. You're looking for some type of reaction. What about this up the top? What do you think that is?
With the white?
Yeah, that white stuff. What is that? Is that bubbling or fizzing or something?
Oh my God!
Guys,
it stinks. No, it smells like rice to me. It smells like rice.
Does it bubble?
Yes.
Is it changing temperature? We're not going to check the temperature, but are you getting a reaction? You know the signs of a chemical reaction? Changes color, changes temperature, it starts to bubble. Do you think you're having a chemical reaction there?
Yes.
How many of you think that there is life in sample A? Nobody. Okay, why not?
Because nothing happened to it. It was just water.
Okay, it just pretty much sat there. How many think there is life in B? Okay, good, excellent. How many of you think that there is life in sea? Okay, good.
Like you see all this like what is all this around? It's like it's like fizzing up. You see, it's got 2 layers of water. See, one white and one's like a caramel.
Right. Okay. Now remember, this is a fungus. This is actually showing signs of growth, reproduction. The cells are multiplying. So basically, what you are seeing here is it is doing exactly what it's supposed to be doing. It is following the criteria for life. Okay, we're back from the classroom now, and let's see if when we revisit our beakers A, B, and C, we get the same results that the students got. If we take a look at beaker A, you can see there's still no reaction or anything going on with beaker A, okay? And I believe that's the conclusions the students came up with. If we take a look at beaker B, as you can see, there is some major reaction going on here, okay? Definitely something happening in this particular beaker, and I believe that's also what the kids recognized in the classroom. Beaker C, even though there was a reaction in the beginning, it has stopped. And if there was true life going on here, if there was true type of reaction going on here, it would not stop. It would be continuing. So consensus is that life exists only in beaker B. Okay? So what we're going to do now after this is we're going to move on to our extensions and our resources. Christy and I hope that you have enjoyed yourself today in the presentation of It's Alive, but it doesn't have to end here. You can go back to the virtual campus and have access to some of the extension activities that go well with the lesson that you have just seen. For example, we have Getting There, which is a navigation and trajectory lesson on the kids navigating to the planet Mars itself. We have another lesson, Tricky Terrain. That's where the students are able to investigate planetary soils. We have Lava Layering, where they can actually make and map their own volcanoes. We have a lesson on Mapping Mars, which is a geological sequence of craters and river channels.
NEON is another site you can visit, NASA Educator Online Network. Here you can go and explore ideas that other teachers have about this lesson. You can even post your own ideas. Now that you have participated with us, look for this icon and take the survey. This survey will give you points towards the recognition opportunities at the NASA Explorer School.
We'd like to thank you again for joining us today, and we hope to see you again in the near future on our next presentation of our very next module. Thank you again.